Good morning. Happy Thursday. Feels like a Friday because you have Friday off tomorrow. Um, Welcome to another fabulous episode of How Many Tabs Are Open on Mr. Johnson's computer? We have two, four, six, 8 tabs open. Today we're going to continue to look at data represented in pictorial ways. This one being a dot plot. All right, so the dot plots we looked at yesterday were weird dot plots. They used categories with dot plots. Today's dot plot looks more like a normal dot plot with numerical data. All right, so if you look at all the pieces of data on our dot plot, they're all numbers. All right, so typically, normally, um, a dot plot should have numbers instead of categories like it did yesterday. Right? If you're like, what are you talking about, Mr. Johnson? Let's take a look real quick. Um, on yesterday's assignment, your your dot plot. Oops, it's not this one. It's the other one. On your assignment from yesterday, the dot plots actually had categories, which was weird because that's not typically a thing. But as you can see, instead of having numbers on our dot plot, we had categories. We had months, right? So that's the biggest difference between today's dot plot and yesterday's dot plot is today's has numbers as the categories. All right, so this is what you will typically see with the dot plot, numbers down here instead of words. All right, we still got to read the labels. So what is the label here? Times for 100-meter sprint. So it looks like all of these represent how long it took someone to finish a race. A 100-meter sprint is just like a race where you run 100 meters as fast as you can. And if you have the smallest time, you win. All right, that's the thing about a race. Usually, when we're thinking about sports and games, the biggest number wins, right? In a race, in golf, the smallest number wins. All right, so the smallest number, the smallest piece of data that actually has a point is the winner, all right, or a dot. The smallest piece of data that has a dot would be the winner of this race, okay? So these are times for 100-meter sprint. That's once again, this means this is how long it took these people to finish their race. One person finished the race in 10 and 1/10 seconds. One person finished the race in 10 and 2/10 seconds. Four people finished the race in 10 and 3/10 seconds. When you're like running a race, like people sometimes cross the finish line so close together, you have to measure in tenths or 100ths of a second, less than a second. Because if two people come in at 10 seconds and the next time is 11 seconds, if you don't use those tenths and hundredths, it would just be a tie if everybody came in. All these people either 10 and 1/10 or 10 and 7/10, all these people would be tied if we did not use those pieces of a minute. So remember, these are like fractional pieces, decimal pieces, 1/10. So this is 10 seconds and 1/10 of a second. This is 10 seconds and 2/10 of a second. This is 10 seconds and 3/10 of a second. All right. So as we can keep on going through this, four people finished in 10 and 3/10 seconds. 1, 2, 3, 4, 5 people finished in 10 and 4/10 seconds. 1, 2 people finished in 10 and 5/10 seconds. 1, 2, 3 people finished in 10 and 6/10 seconds. One person finished in 10 and 7/10 seconds. If there is no dot above the time, or there's no dot above the number, that means there's no data. So nobody came in at 10 and 8/10 seconds. Nobody came in at 10 and 9/10 seconds. But at 11 seconds, we had our final person cross the finish line. All right. So these are all pieces of data that represent how long it took somebody to finish a 100-meter sprint, which is a race. And once again, in a race, the shortest time wins. Because think about it this way, if you run around the track and it only takes you a minute, and I run around the track and it takes me 2 minutes, who ran around the track faster? You did, because it took you 1 minute. It took me 2 minutes. Your smaller number beats my bigger number, right? So let's read the word problem and let's see if it matches our dot plot. All right. So the person with the fastest time ran exactly 10 seconds. The person with the slowest time ran exactly 11 seconds. So we are looking for a dot. We're looking for one dot above the 10, and we're looking for one dot above the 11. All right, because if there's a dot above the 10, that means that the first person finished in 10 seconds. If there's a dot above the 11, that means the last person finished in 11 seconds. So let's take a look. The person with the fastest time ran exactly 10 seconds. If we look at 10, there's no dot. There's no dot above 10. So the person with the fastest time was not the person. There's nobody here. The next smallest number is 10 and 1/10. And we do have one person that finished at 10 and 1/10 seconds. So I don't agree with this first line. The person with the fastest time ran exactly 10 seconds. I don't agree with that. The first person with the fastest time ran it in 10 and 1/10 seconds. All right, let's see. The person with the slowest time ran exactly 11 seconds. So the slowest time on our chart is 11. We don't have any bigger numbers than that. So our dot plot ends at 11. So that would be our slowest time to finish the 100-meter sprint. And there is, in fact, one person who finished the 100-meter sprint in 11 seconds. So the person with the slowest time ran exactly 11 seconds. I do agree with that statement. All right. So what I notice is I notice that we are looking at a dot plot that represents how fast people finished a race. I notice that this dot plot represents time. I notice that this dot plot has numerical pieces. I notice this dot plot has a number line. I notice this dot plot. There are the most people finished at 10 and 4/10 seconds. I can tell that because there's 5 people that finished at 10 and 4/10 seconds. So there's a lot of noticings. You can use any of those noticings. Remember, you're using all 4 sentence stems, including I wonder. I wonder is not a I wonder nothing. All right. And I know you're thinking, like, but what if I wonder nothing? The thing about an I wonder question is basically anything that you've been presented in life, you can make a wondering about. All right. It's one of those things that it's really, really it's a helpful tool to show whether you understand the material fully, because it's really hard for me to ask a question about something if I don't understand it at all. So one of the things that you can do is, obviously, you can listen to the suggestions on here. You can think about where this goes in the future. You can build connections to what you've seen in the past. All right. So remember, the I wonder part is necessary. Writing I do not wonder anything or I wonder nothing, that's not going to be acceptable. All right. So they are the same. Almost all of the data matches. They are the same because the person with the slowest time did run 11 seconds. They're definitely the same because the person with the slowest time ran exactly 11 seconds. That does match with our data over here. They are different. They are different because the person with the fastest time ran 10 and 1/10 second on our dot plot. The person with the fastest time ran exactly 10 seconds in our words. So this does not match this statement. This lack of a dot means that nobody finished in exactly 10 seconds. All right. So things I wonder. I wonder, first off, could we represent this on a bar graph? Right? Um, Chances are you're not going to represent numerical data on a bar graph. Right? You could, but this dot plot is the most beautiful way to represent that data. I wonder if you could represent this data on a frequency table. Yeah, we could represent this data on a frequency table. These would be our categories: 10 seconds, 10 and 1/10 seconds, 10 and 2/10 seconds. And then we would just write as many tally marks as there are dots. All right. So if you're thinking, well, if we could make a frequency table, we could make a bar graph. Absolutely, you could make a bar graph. But just remember, when you're dealing with numerical data, oftentimes the dot plot is the easiest way to represent numerical data. If you have those categories that are words, like we wouldn't make, usually you're not going to make a dot plot that says like lions, tigers, bears, oh my, what are the favorite animals at the zoo? you're not usually going to see a dot plot with those types of categories like lions, tigers, bears. It's usually going to be numbers like this, numerical representations. All right. I also wonder, like, if this is more complicated than the fourth grade version. If you remember, this is something that you learned in fourth grade. I wonder, you know a lot about what you learned in fourth grade. So you could say, I wonder if we're going to do this year when it comes to dot plots. All right. So remember, use all four stems to receive full credit. And we just went over the stems. And you could even say, like on the wonder, you could fix it. You could say, I wonder if they forgot to put one dot above 10 seconds so it matches the words. See, that's like really thinking ahead. And as you can see, like you could totally understand this problem, but that wondering, it's a good question, right? Did they forget to put the dot on the dot plot above the 10? Or did they just put it in the wrong place and accidentally put it over 10 and 1/10? These are the types of wonderings that you would ask yourself if you did a test and you saw a mistake, right? So think about it like that. All right, so that's basically it for today. You have your quiz. Your quiz is on all of your data representations for the week. We're going to continue with data next week. So just keep all this stuff in your brain, keep it fresh over your long weekend. Please reach out to your teachers if you have any questions. Like and subscribe to the video if you feel like it. And I hope you have a wonderful day. And I will talk to you later. Bye.